Hello everyone and welcome back. In this video, we'll talk about the different types of errors that we can make when we perform a hypothesis test. Now, whoever came up with naming these errors were not very creative, and these are called the type 1 and type 2 errors. Now, a type 1 error occurs when the null hypothesis is true, but we mistakenly reject the null hypothesis. And a type 2 error occurs when the null hypothesis is false, but we fail to reject the null hypothesis. And a good analogy that we can use to compare these types of errors come from the criminal justice system. Now, in a court trial, we typically hear the phrase, "The defendant is assumed innocent until proven guilty." So recall that in a hypothesis test, we begin by assuming that the null hypothesis is true. And so the null hypothesis is that the person is innocent. And the alternative hypothesis is that the person is guilty. Now, if the defendant is truly innocent, but the jury's decision is that the defendant is guilty, then this is a type 1 error. So we rejected the null hypothesis, even though the null hypothesis was actually true. Now, if the defendant was truly guilty and the jury's decision is that the defendant is guilty, then this is the correct decision. And so there are no errors in this case. And similarly, if the defendant was truly innocent and the jury's decision is that the defendant is not guilty, this is also the correct decision. But if the defendant was truly guilty and the jury's decision is that the defendant is not guilty, then this is a type 2 error. So we failed to reject the null hypothesis even though it was actually false. The decision was that the defendant is not guilty, but in fact, the defendant was guilty. So this is a type 2 error. So during a trial, a type 1 error occurs when we convict an innocent person, and a type 2 error occurs when we set a guilty person free. So we can look at finding the probabilities for making these types of errors. So the probability for a type 1 error, which is the probability of rejecting the null hypothesis even though the null hypothesis is true, is given by alpha. Notice that this is the same notation as the significance level of the hypothesis test. And that's because the probability of making a type 1 error is the same as the significance level. So when we're choosing the significance level for our hypothesis test, we're also setting the probability of making a type 1 error. Now, the probability of a type 2 error is denoted by beta, which is the probability of failing to reject the null hypothesis even though the null hypothesis is false. Now, finding this probability is a bit more involved because it will depend on the value we choose for the parameter in the alternative hypothesis, and we won't be concerned about calculating this type of probability. Now we define the power of the test to be 1 minus beta, which is the probability of correctly rejecting a false null hypothesis. So this is the probability that we made the correct choice when we reject the null hypothesis in our test. Now the two types of errors that occur in a hypothesis test are dependent on each other. So if we assume that the null hypothesis is true, meaning that P equals P naught, then the sampling distribution model will be centered at the hypothesized parameter value. Then the probability for a type 1 error is given by alpha, which is the area in the right tail. And so for this example, we're considering the case of an upper-tailed test. Now, if the null hypothesis is false, then the mean of the sampling distribution will be centered at some other value. So we'll call this value P. And the probability for a type 2 error is going to be given by the area in the left tail. And so if we were to draw the line that goes through these two sampling distribution models, then beta will be given by this left tail. And then the power is going to be 1 minus beta, which will be the area in the right. Now imagine what would happen if we were to lower alpha by setting the significance level of the test smaller. So this would cause this vertical line to shift towards the right. Okay, so if we decrease alpha, then the vertical line will be shifted. And if we lower alpha, then this would cause beta to increase. And so lowering alpha would cause beta to increase and vice versa. If we were to increase alpha by setting the significance level higher, this would cause this vertical line to shift to the left. So by increasing alpha, this would cause beta to decrease. So they are dependent on one another. Now, if we were to obtain a larger sample size, this would generally cause the standard deviation of the sampling distribution to decrease. And if the standard deviation decreases, this would effectively cause beta to decrease, which would mean we would increase the power of the test. So let's take a look at an example of the types of errors that can happen in a scenario and the consequences of making such errors. So suppose that a report shows that a drug that alleviates migraines turns out to have a nasty side effect. A researcher wants to study the drug and look for evidence that such side effects exist. So the null hypothesis is that we assume there are no side effects to the drug. And the alternative hypothesis would be that the drug has side effects. So suppose that the test yields a low p-value and the researcher rejects the null hypothesis, but there are actually no ill side effects of the drug. So what type of error occurred and what are the consequences? So since the researcher rejected the null hypothesis, even though the null hypothesis is true, then this is a type 1 error. So since the researcher concluded that there are side effects to the drug, even though the drug has no side effects, then the drug would not be produced and people would be missing out on a very beneficial drug. Now let's suppose that the test yields a high p-value and the researcher failed to reject the null hypothesis, but there are actually side effects to the drug. So what type of error occurred in this case, and what are the consequences? Well, since the researcher failed to reject the null hypothesis, even though the null hypothesis is false, then this is a type 2 error. And so the researcher concluded that there are no side effects to the drug, even though there are actually side effects. And so the drug would be produced however, people that are taking the drug would suffer the side effects. And so this concludes our lesson for this video. In the next video, we'll talk about comparing two different population proportions, and I'll see you then.